In this assessment, we're given a reaction and asked to predict what would be the likely transition state. Now, if you look at these two transition states, the difference between them is here the carbon-bromine bond is more broken, here it's less broken. How do we know it's more broken? Because it's a longer dashed bond, and we have a bigger partial negative and a bigger partial positive. So that suggests that the bond, again, is more broken. Essentially, this is an application of the Hammond postulate. And when we look at this reaction going from a neutral alkyl halide to a cation and a bromide, we have to ask ourselves, is this probably an uphill or a downhill step? Well, going from neutral to two charges is probably going to be uphill. And so if we imagine this as being an uphill step in a reaction coordinate diagram, we can then look and see which is closer to the transition state, or what is the transition state closer to, the reactant or the product. Well, it's clear based on their location that the energy of the transition state is much closer to the energy of the product. And so with these being the products of the reaction, we're going to expect the transition state to look more like the product. Well, when we look at the product, what do we see? We see that this carbon-bromine bond is almost completely broken, and we have a full -1 charge on the bromide, a full +1 charge on the carbon. Thus, the transition state here on the left that shows bigger partial charges on the bromide and the carbon and a much more broken carbon-bromine bond must be the transition state of this reaction.